1.4 number 8. So I am going to go back to homework. And just because I didn't hit save, it still saved me where I was. I'm going to go to 1.4 number 8. Don't think that all the homework is like this, because it's not. I just picked out the hardest ones. Number 8. Okay. Human Resource Department and a certain company wants to conduct a survey regarding worker benefits. The department has an alphabetical list of 5,465 employees at the company and wants to conduct a systematic sample of size 60. What is K? Ms. Cooper never talked about K. On your test, did I say solve for K? No, I just said tell me the two types of these things. That's all you got to know for your test. Now, you can easily go in your homework and come to question help and say, view an example. And let me show you how easy. Maybe it won't let me. It says K is the big N over the little n. The big N is the number of employees, the little n is the sample size. So the big N is the population divided by the sample. So let's go back to our problem. The big N is the population, the little n is the sample. So we go to our calculator and we type in the big N, which is our population, 5465. It says all. The little n is our sample. Okay? Now, when I went back to the view, it says we compute in and round down. So no matter what, if it was 91.9, we would still round down because that's what this little thing said right here. So our K is going to be 91. Not as hard as what it looked like, right? All right, then it says, so we can see it. Then it says, determine the individuals who administer the surveys randomly selected from 1 to K with a random sample of 5. Ooh, I don't know what that means. So I'm going to come over here. Now, this one started at 10, and my K was 85. So I'm going to use their numbers. So, they wanted me to do blanc, 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 dot, 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 blanc. Now, my K for that problem was 85, and I was doing a sample size of 10. So my first answer, randomly selected 10. My first answer was 10 plus 85. Then my next one was 10 plus 85 times 2. Or 2 times 85, let me write it in order. Ooh, that doesn't want to erase. 2 times 85. I don't think they have another one.
The first one is 85, then it goes to...
Oh, that's where the third one is. Thank you. Dot, dot, dot. And then my last one is going to be 10 plus 85 parentheses 40 minus 1. Now I have to go back and say, where did the 40 come from? The size at the beginning. My sample size at the beginning. So let's take this and look at our problem. So for our problem, what was our K? 91. So that's what we're going to start with. Now here, it's gonna be 91 plus, what number was in this paragraph?
305.
5. So it's gonna be 91 comma 96. Then, we're gonna do 5 plus 91 times 2. Somebody help a sister out. You getting a booty call?
No, that's not right.
What is that?
187.
187, dot, dot, dot. And then down here, it's gonna be 5 plus 91 times, now 40 came from our sample size up here. So what number are we gonna use?
60.
What's that give me?
5374.
5374. So when I roll that bad boy down, 596, 187, 5374. Now, on my test, do I have to know this problem?
No.
The only thing I had to know on the test is these two problems right here. Identify the sampling technique, which were these 5 problems. Easy breezy?
Yes.
And just to show you that all problems are not this hard, let me scroll back for a minute. To determine her blood pressure, Brittany divides up her day into 3 parts, morning, afternoon, and evening. What is that telling you? Classrooms. So it's either going to be which one of these 2? Cluster or stratified. She then measures her blood pressure at 2 randomly selected times during each part of the day. Stratified. So we have morning, afternoon, and evening. We go to morning. We don't use all of the morning times. We just pick 2. 2 and 2. We're not taking the whole cluster, so this one's going to be stratified. Now, if you happen to miss it, oops, I happen to miss it, it's going to mark it wrong, and it's going to let you try 3 times. And after 3 times, it's like the 3-strike rule. After 3 times, you get to try it again. It's going to give you an X, but it lets you try it again. So let's do another one. Oh, same freaking problem. Stratified. There's no reason, y'all, why you should make 100. Look what that turned into. A check. Everybody should have 100 average. Yay? Alright, so that is it, I think, for 1-3 and 1-4 homework. So we are officially done with chapter 1. Whoop whoop, rolling on to chapter 2. Let me save this real quick. What is it, 6-3-19? Sit back and enjoy the ride. It's going to get hard before we know it. 2.1, qualitative. What do we say about qualitative? Letters. Quantitative is numbers. So when we take qualitative data, we put it on a bar graph. When we take quantitative data, we put it on a histogram. Do we know the difference between a bar graph and a histogram? I don't remember what a histogram is. Let me show you. Oh! Tell me the difference between a bar graph and a histogram. The spacing, that's it? The bars do not touch on a bar graph. Here, the bars touch. Only difference. So, on a histogram, the bars touch. Here, the bars do not. So if we were back in elementary school and I said, let's go out at recess and let me ask you your favorite color. And we did red, blue, and green. And like 3 people said red, and 4 people said green, and 3 people said blue, or whatever. Then I would make a bar graph. This would be my red, this would be my blue, and this would be my green. And the reason they don't touch is because red has nothing to do with blue, has nothing to do with green. They're totally separate. Okay? Now, if we go to recess, and I say, how many miles do you drive to school? 0 to 9, 10 to 19, 20 to 29. 3 people said that, 4 people said that, 2 people said that, 30 to 39, 4 people said that. So this would be 0, 10, 20, 30, and 40. These touch because this bar represents 0 to 9. 3 people said they went somewhere between 0 and 9 miles. And as soon as 0 to 9 miles bar ends, 10 miles starts. So these bars are connected because as soon as one stops, the next one starts. So this is dealing with number data because the numbers keep going on. This is dealing with letter data because the letters have nothing to do with each other. All right. If the data is not organized, it's called raw data. When I take up this is raw data. I just have a bunch of numbers. I have a bunch of majors. I have a bunch of, you have a cell phone or not. I have a bunch of math sucks and I don't like it. And I just have a bunch of stuff. But if I go home tonight and I make a bar graph, I can come back on Wednesday and give you 3 people are majoring in NSM, 5 people are majoring in engineering, 3 people are majoring in whatever. I can turn the data into some kind of graph. But right now my data is raw data. It's just numbers and stuff written down. But once I organize it, I can display it in a table or a graph, something that's easier to read. Okay? Now, what I just did right here is called a frequency table. Y'all did them back in elementary school. You wrote what you're looking for and you did little tally marks. Those are frequency tables. We can do them with numbers, we can do them with words, but we're going to make a frequency. So if I scroll down just a little bit, so if I say favorite color, and we do red, blue, green, and pink. Pink's my favorite color. So, 2 people like red, 2 people like blue, 1 person likes green, and 5 people like pink. That would be my frequency. So that whole chart is called a frequency distribution. It tells me what question am I asking. This is my variable. And what they say. This is my raw data. Okay? Now, we want to go one step further. We want to talk about relative frequency. How does the frequency relate to everybody that I asked? So, for relative frequency, I'm going to go one step further. How many people did I survey? 10. Good job. many people like red out of everybody that I asked? How many people like red? Out of how many people did I ask? So my relative frequency is going to be 2 out of 10, or we can say 1/5. That would be the fraction answer. How do I turn that into a decimal? If we need to do it in our calculator, we would do 1/5.2. That would be my decimal answer. How would I turn it into a percentage? Whoop whoop. Whoop whoop. To turn a decimal into a percentage, you whoop whoop. Take that 0.2. Whoop whoop. Okay. So for blue, what would blue be? Same thing. Oops, OCD, I gotta get my colors going. 2 out of 10, which is 1/5 as a fraction, 0.2 as a decimal, or 20% as a percentage. What would my green fraction be? 1 out of 10. So to turn it into a decimal, we would do 1/10. That would be 0.1. Whoop whoop. What's it gonna be? 10%. All right, what would my pink be? 2 out of 10.
5.
Just making sure y'all paying attention, just kidding, I didn't read it. 5 out of 10, which is 1/2, which is 0.5, whoop whoop.
50%.
Now, all of your frequencies, what do you think those fractions add up to?
100.
Because all the pieces are going to add up to the whole survey. All of the pieces are going to add up to the whole survey. And because we whooped the whole survey, it's going to add up to 100%. So your relative frequencies always are going to add up to 100 or 1. So when we say relative frequency, we want to know how does each variable relate to the whole group. Yay? Super duper fun. Have we ever heard of Pareto chart? You're going to sound so smart when you get out of this class. Ugh! You don't remember Pareto? Nautica. Did you learn anything in 120 last semester? Pareto?
Oh, they need this
I don't think I wrote that right. Y'all, I'm not an English major, sorry. This is a Pareto chart. Pareto chart is a fancy name for a bar graph that goes in descending order. Oh. Oh. Mathematicians are paid lots of money to confuse you by giving simple things fancy names. That's all a Pareto chart is a bar graph from greatest to least, descending order, going down. That's it. Oh. All right, let's look at some problems in the book. We're on page 70. Page 70. We already had one quit.
Why? What'd you do?
I'm that bad.
No, you're not.
He quit in the break. He's taken physics, he's taken electrical engineering, and he's taken circuits.
I quit too.
I know. He's like, I didn't want to be rude, but I just don't think I can do this
Not in the
physics.
summer.
I know. He said he was killing himself and wanted to try it, but
13, I think, so.
yeah, he was number 14, and I got a message that, from Pat Malicki, that one of them said he couldn't be here today, but he's gonna be here, so
Y'all got a good one. Y'all enjoy
Whatever.
this.
whatever.
She's good.
He's my
Y'all have
boss.
fun.
He's my boss, so please say nice things. And he came in and I don't have shoes on. All right, so how to beat the flu bug. So we have a circle graph. And this circle graph, so instead of a bar graph, they've now taken the bars and turned them into circles. But we could have just as easily drawn this as a we could have turned this circle graph into a Pareto bar graph very easily. I knew this was my largest piece of the pie, so I made it the biggest one. This was my next largest piece of the pie, this was my next largest piece of the pie, and this was my smallest piece of the pie. Oh. Let's answer a question. What percentage of the population thinks flu shots are the best way to beat the flu?
25%.
Don't make life harder than it is. 25%. They're making sure that you can read the data, the raw data that has been turned into graphical data. All right, here is what kind of graph?
Bar,
Bar graph that has been turned into a
Pareto.
Pareto chart. All right, which position had the most MVPs? Outfielders, because it's the tallest. How many MVPs played first base? 15. How many more played outfield than first base? What does more mean we need to do? Subtract. So we're going to do outfielders minus first base. So how many outfielders are there? Minus how many first base?
15.
Yay? Now, notice that when you're doing this one, that on this side, there is frequency. Because sometimes it'll be frequency and sometimes it'll be relative frequency. So for this one, this is telling you that there are 9 people out of everybody that said third base. So if we wanted to know what percent said third base, we would do 9 out of everybody. So frequency just means this many people said, 9 people said this, 15 people said this, so that's frequency. Okay, how many people said it? All right. This one is also frequency. So frequency is the number of people that said it. What does that number say? I look like I'm seeing double again. Hispanic 12, 3, something, something.
745.
Oh, you're good. Did you get it out of the book? All right. Of the impoverished, what percent were Hispanics? Of the impoverished, what percent were Hispanics?
12.745.
Okay, so do we agree that the Hispanics were 12,745? Is that the answer?
That's the number, that's not the
That's the
percentage.
number of people who said Hispanics. We need the percentage. So how do we find percent?
Multiply
Before we, percent is screaming woo woo.
by,
But what do we have to have before we woo woo?
The
a
total.
decimal.
A decimal. And what do we have to have before we get the decimal?
A number.
A number. And how do we get that number? Divide by something. So, there's a couple of ways we can do this. Some of us may remember part over whole equals percent over 100. Some of us may remember is over of equals percent over 100. Or some of us may even just say, I want to take a fraction, turn it into a decimal, and then get my whoop whoop on to make it a percentage. All of those are gonna work. So my part, or my is gonna be the Hispanics. My whole, or my of, is gonna be everybody, like the population. So this represents my sample, the people I asked, the Hispanics, the part. The population is everybody. So how am I gonna get my bottom number?
And all of them.
Add all those numbers up. So my bottom number is going to be the 29,936 plus the 11,041 plus the 12,745 plus the 1974. That's going to give me 12,745 over 55696. Is that what you got? So if I do it as one of these two methods, it would be 12,745 over 55696 equals X over 100 because I'm trying to find the percent. So if you want to go the is over of or the part over whole, you would do it this method and you would cross multiply. So what would I do next?
12,745
I would take the 12,745 and do what? Times it by 100. And then divide by 55696, and that would give me my answer. Now, if you want to do it, and let me scooch him down. If you want to do it the other way, so this is if you want to do it that way. If you want to do it the other way, that's your fraction. Your fraction is 12,745 divided by 55696. That's your fraction. You just turned it into a decimal. And then what do you need to do with your decimal? Whoop, whoop. Just want to hear you say it. So, there's your fraction. Your decimal is 0.2288 blah, blah, blah. And to get your percentage, you got the whoop whoop, which is the 22.88%. So either way, we're going to get the same answer. So if you do part over whole or is over of, you don't have to whoop whoop. This is your whoop whoop. Multiplying by 100 is the same thing as whoop whooping. So if you use is over of or part over whole, the whoop whoop is built in. If you don't use that, then you got to get your whoop whoop on. I don't care which method you use. All right. What percent of respondents believe divorce is morally acceptable? Now, let me scroll up for a minute. Remember, over here was the frequency. How many people were asked? For this graph, this does not represent how many people were asked. This represents the percent that were asked. So pay attention to what they're giving you down here. This is not the frequency anymore. This is automatically the percent. What percent of respondents believe divorce is morally acceptable? 69%. So this time we don't have to do part over whole because it automatically gave us the percentage. Oops. Scooch him down. Myself a little bit of room. Approximately what percentage of identity theft was loan fraud?
Five %.
You may disagree. Travis, you agree? Relative frequency, remember, if I scroll back, relative frequency can be written as a fraction, a decimal, or a percentage. They gave you on the chart relative frequency as a decimal. They gave you relative frequency as a decimal. So our relative frequency is going to be 5% because we turn this decimal into a percent by getting our whoop whoop on. Very good. Which one would you most likely to be? Boys are blue, girls are green.